Welcome to Fairfax County Public Library. We are delighted to have you join us as we host Great Decisions. Great Decisions is America's largest discussion program on world affairs. The program meets to discuss the most critical global issues facing America today. Our topic this month is outer space policy, and our guest speaker is Dr. Scott Pace. Back as our moderator is retired Foreign Service Officer Mike Carpenter. So, Mike, when you became a foreign service officer in the dark ages, did you ever dream that humans would someday colonize Mars and that you'd get an assignment there?
You know what, Adrian, I really did. And if Elon Musk gets cracking, we'll soon have an embassy on Mars, and I can emerge triumphant from my retirement and make my dream true. I'll be the first U.S. ambassador to Mars. So, Flash Gordon, eat your heart out.
Well, Mike, may your dream come true real soon, and please don't hurry back.
Please, Adrian, I don't sense a sense of loss here, but I won't be able to moderate from Mars, you know. You're going to miss me. You will. But for right now, just roll the video while I go sulk.
Okay, Mike, but do return in time to introduce our guest discussant, will you? Now, everybody fasten your seatbelts for outer space. Here's this month's video. But first, a few notes about this afternoon's programs. Your audio feeds will be muted during the program video. Once the program is over, our moderator, Mike, will introduce our invited guest speaker, Dr. Scott Pace, and we will begin our discussion. We look forward to a lively exchange of views. Are there any questions? If not, I'll begin the program video.
Welcome back, ladies and gentlemen, to Great Decisions 2022, a 9-lecture masterclass brought to you by the Foreign Policy Association. Topic number 1, changing demographics, gives way to a very different challenge here with topic number 2, outer space. For as long as humans have existed, we've looked to the skies with great wonder and curiosity, marveling at the planets, the stars, the systems above us, always trying to make sense of it, looking for order and looking for patterns. Some civilizations believed that the gods resided in the heavens, and they simply left it at that. But as knowledge began to expand, we began to theorize about our place within the system. It was quite popular to believe that the Earth was the center of the system, with all things, including the planets and the stars, revolving around the Earth. Ptolemy, part of the Renaissance of the 16th century, challenged that. A mathematician, an astronomer, he introduced the idea that perhaps the sun is at the center of our solar system. Interestingly, 18 centuries earlier, a Greek mathematician and astronomer reached the very same conclusion. Now we understand that all life began in outer space with the Big Bang. We begin with a thumbnail sketch of outer space. It is, simply put, the area beyond the Earth. We do not have a consensus over the line that separates airspace from outer space. The most common dividing line is called the Kármán line, which is 62 miles above sea level. We do not know the overall size of outer space, but what we do know is that there is no friction there. 3 main considerations for this foreign policy challenge: the space race, regulating outer space, and private space travel. Once we've completed those, we'll be ready to consider American foreign policy options. Let's start with the space race. 1957 was a shock to the world. Sputnik, a Russian satellite orbiting the Earth. We never saw this coming. It immediately put outer space as part of the superpower competition. Everything changed in 1957. The space race was on. The United States created NASA with the sole purpose of exploring outer space and eventually reaching the moon. But in 1961, the Soviets beat us again. A cosmonaut from Russia became the very first human to enter outer space and to return to Earth safely. NASA, of course, continued its pledge to beat the Russians to the moon. John F. Kennedy was there to challenge America as well, to say that we can beat the Russians to the moon we can win the space race. And we did win that space race. In 1969, an American lands and walks on the moon. Here we have that iconic photo. NASA continued its exploration of outer space with many successes and sadly far too many failures. Here you see the Challenger as it exploded shortly after takeoff. The International Space Station's establishment in the late 1990s was a major step forward, both in scientific progress but also in international cooperation, because both the Russians and the Americans utilized the space station along with a large number of other international scientists. And more recently, we have made it to Mars with the rover, collecting samples so that we can learn more about the red planet. So what's next in this space race? Expeditions to other planets, settlements on the moon, maybe interstellar space missions, or perhaps outer space becoming a militarized battleground. We now consider the regulation of outer space. Prior to the First World War, there were several theories on a nation-state's relationship to the air above it. On one end of the spectrum was that collection of countries that argued, using the old Latin phrase usque ad coelum, that a nation's sovereignty extends into the heavens. There are no limits. The country enjoys ownership over everything above it. On the other end of the spectrum, some countries argued for res communis, or common heritage, meaning that airspace is open to all. It can be explored by any, and no nation state can claim sovereignty over it. The point in between would be a line separating airspace from outer space, with the nation state enjoying sovereignty up until that point. And then above, it would be res communis. The experience in World War I greatly influenced the global consensus on airspace law. The Germans in particular were able to use their air balloons. They did so for purposes of espionage, for the movement of troops, and for the dropping of bombs. And it's also in World War I that we saw military aircraft play a very important role in the outcome of battles. As a result of that experience, shortly thereafter at the Paris Convention, it was determined that each nation state owns the airspace above it. Usque ad coelum became the reigning principle to regulate airspace and outer space. Sovereignty extending into the heavens, permission must be requested and provided before any aircraft can enter into the airspace of another country. Sputnik changed all of that. In the late 1950s, we experienced something called rebus sextentibus, a fundamental change of circumstance that renders existing law irrelevant. When the Soviet Union was able to put a satellite in outer space orbiting the Earth, it shattered the idea that nation states could effectively control airspace into the heavens. Immediately, it was understood we need a line separating airspace, which is the sovereign domain, the territory of the country, from outer space, which is res communis, or common heritage. So we then moved from one end of the spectrum to the center. Negotiations were underway to determine exactly where that point would be, that line separating airspace from outer space. What does the new legal regime look like? Well, there is consensus that below this line is the airspace of a nation. It is their sovereignty. Above that line is outer space, common heritage, open to all for exploration, and no one can claim it as their own territory. State sovereignty versus common heritage. The problem is we don't have a consensus on that line. Earlier I mentioned the Kármán line, that's 62 miles. That is rapidly being challenged by mathematicians who argue actually 50 miles makes a lot more sense. And then we have the United States, whose position is it's unnecessary to have a global consensus on the dividing line between airspace and outer space. We don't need to do so, and each nation state can determine, based upon their capabilities, where the line separating air and outer space exists. One of the reasons that the United States does not want a very high divide between common heritage and state sovereignty is that we have advanced military aircraft that can fly very high, but certainly not 50 miles high, in order to spy on other countries. So if the line is low enough that our aircraft can fly above it, we're technically in outer space, common heritage, but we're spying on other countries. This is the Red Bull space jump from a few years ago. He leaps from 96,000 feet. It certainly looks like outer space, and it was billed as a space jump. But as you can see, that's only 18 miles up. For most of the world, between 50 and 62 miles is where outer space begins. Codification of the legal regime. Now, legal regime means a collection of international agreements relating to a particular topic. In this case, it's outer space. It doesn't mean that the treaty has to be exclusively about outer space, but rather it has an important impact on the laws regulating outer space. The very first treaty is the 1963 Limited or Partial Test Ban Treaty, because this treaty during the Kennedy administration made it illegal to test nuclear devices in outer space. Then there was the 1967 Outer Space Treaty, followed by the more specific 1979 Moon Treaty. These three documents make up the corpus, the body of the legal regime on outer space. And what they say collectively is that outer space is common heritage, meaning every nation state can explore it. That when astronauts go up, they are envoys of humanity. That states are responsible for whatever they put in outer space, and that no military use of outer space will be permitted. These are the countries that have signed and or ratified the Outer Space Treaty. Those in green have ratified. Those in yellow, Horn of Africa, a few countries in South America, Middle East, they have signed, but they have not ratified. And then those in red have neither signed nor considered ratification. As you can see, this is considered a universal treaty, and all of the space nations are represented in the register. In the 1980s, there was a grave challenge to the basic regime principles of outer space because the United States, under the Reagan administration, pursued Strategic Defense Initiative, SDI, or what many of its critics and even proponents referred to as Star Wars. This is the militarization of outer space for defensive purposes. Let's begin with the logic of Strategic Defense Initiative. If the Soviet Union was to launch an ICBM, nuclear-capable missile, towards the United States, there are three stages where we have an opportunity to attack it. There is the initial stage, that is from the blast, the launch, up until roughly the outer edges of airspace. The problem is that Siberia is so far away and it takes so little time for that rocket to reach the limits of airspace, we probably could not bring it down effectively. Add to that the fact that we don't really know where that missile is heading. It could be a test fire. It could be aimed at the ocean. We really don't know that, and if we're going to shoot down every Soviet missile the moment they're launched, that could very quickly lead to a tit for tat and a rapid escalation of conflict. So stage one, launch to outer space, is out. Stage three, when the missile returns from outer space and begins its descent, is also highly problematic because of the technology of the 1970s and early 1980s called MIRV, Multiple Independently Targeted Re-Entry Vehicles. What this means is that one ICBM, upon re-entry, could open up and release 4, 5, or perhaps even more independently targeted re-entry vehicles, each one of which is nuclear capable. So suddenly, if that missile reaches the American airspace, it turns into 4 or 5 nuclear bombs almost immediately. Taking all of those out would be a grave challenge. So it really only leaves us with stage 2, which is outer space. As noted earlier, there is no friction. That means objects move in a very clean, straight, consistent line. That means the missile is highly vulnerable to attack if we have defensive capabilities in outer space. Star Wars, or Strategic Defense Initiative, was designed to reside in outer space, to wait for the ICBM to enter outer space, begin its long, flat plane of travel, and then shoot it with a laser, causing it irreparable damage. Or if that technology wasn't ready, simply throw a bunch of rubble in front of it, metal and the like, that the spacecraft would then fly into, causing it great damage. That's the logic of Strategic Defense Initiative. What was Mr. Reagan really after? This is a question we cannot answer all of these decades later. There are a couple of viable possibilities. Maybe he really did want to provide a nuclear umbrella for the United States, to protect us against a Soviet first strike, to protect us against the first strike of any other nuclear nation, or maybe to protect us against an accidental launch. When pressed on the issue by our allies, Mr. Reagan said, we'll share it with Western Europe. When pressed further, he argued we might even share it with the rest of the world. Fine. Defensive purposes, that was one option. Other end of the spectrum, and what Moscow feared greatly, was that the United States wanted to deny Russia a second strike capability. The superpowers had pursued a policy called MAD, mutually assured destruction, throughout much of the Cold War. If one superpower strikes the other with nuclear weapons, there is a mutually assured destruction because the other can absorb the attack and then launch a counterattack that's so devastating that neither side would survive. So if our aim with SDI is to deny a second strike, then the real purpose of SDI is to make possible a first strike against the Soviet Union. That ends MAD, but it also creates a great deal of instability. Finally, option number 3, maybe SDI was just a bargaining chip. We're going to pursue it, understanding we're going to gain a lot of scientific knowledge, breakthroughs, and insights just from pursuing it. But we'll always have it there to trade off against something large that the Soviet Union has to offer. That theory was tested in 1986 when we have the historic summit in Reykjavik, Iceland. Mr. Reagan on the right, Mr. Gorbachev on the left. They met in Iceland. They talked about nuclear weapons. And very quickly it became clear a lot was on the table. Major issues like an intermediate range nuclear force treaty. This is a treaty that would eliminate an entire class of nuclear weapons that had never been done before. These are the medium-range missiles that were in Central Europe. Then there was the historic possibility of the zero-out option, where the Americans and the Soviets, at the time with over 98% of all nuclear weapons on the planet, would agree to zero out all nuclear warheads. It became abundantly clear, however, as they left Reykjavik and that historic house, that no deal had been reached. Not on an historic level, not on a major level. However, it did pave the way for the later signing of the Intermediate Range Nuclear Force Treaty. First time ever, an entire class of nuclear weapons is eliminated. These two world leaders deserved a Nobel Peace Prize for this document. They would not receive it. Strategic Defense Challenges, SDI, was it ever even possible to reach the point of defending our country from outer space? One of the great challenges was the cost of it. Amazingly expensive. Next is the feasibility. Will it even work? The idea of brilliant pebbles, which is basically throwing space trash in the likely path of an ICBM, was developed because we were having real challenges developing the lasers to target and to destroy the ICBMs. The legality certainly was a question because the United States was a party to the Outer Space Treaty. And what we had to say in the 1980s is that for decades we've been misinterpreting the very treaty that we helped draft and
Oh, come on in.
What the treaty really says is that outer space cannot be used for offensive weaponry. Defensive weaponry, like SDI, we argued,
Just saying.
within the regime. And the
You're most welcome.
And of course, if we're going to militarize outer space, even for defensive purposes, it is very likely to lead to an arms race in outer space. And that is what we see today. Not because of SDI, but just because this is what major powers do. They invest enormously in research. They look to the heavens and they look for opportunity. A Chinese nuclear-capable hypersonic missile was tested in October of 2021, just about a week before this lecture was recorded. This is a game changer. As one American military elite official said, this is our Sputnik era. A low-orbit, maneuverable missile is a nightmare for the United States. We don't have this, and we don't have the ability to defend against this. We're openly admitting that. You see, the difference is that an old ICBM goes up into outer space, it travels very consistently, and then stage 3, it re-enters the atmosphere to search for its target. But the hypersonic flies much lower, Mach 5 speed, and is maneuverable. The Chinese test landed within 24 miles of its target. That's a very dangerous result of a test, because what it means is that the Chinese will need to load that weapon with a nuclear device to ensure that the target is destroyed, even if it lands several dozen miles away. The United States is taking the space race in a different direction with a space force, the development of an entirely new branch of the U.S. military devoted to outer space behavior and perhaps outer space as a battleground. Private space travel is our final consideration. It was Mr. Reagan that promoted it, mandating that NASA encourage private space flight and asking it to regulate all space flight. But it's only recently that the multi-billionaires have been able to fulfill their dreams of reaching outer space. First, it was Elon Musk with SpaceX. Then it was Richard Branson with Virgin Galactic. And then more recently, Jeff Bezos has entered the space race as well. Competitions are certainly underway in outer space. Governments are exploring the outer limits. States are rapidly moving in the direction of militarizing outer space, and private companies are commercializing the space above that line. What they'll all contend with is a very crowded field, quite literally. 6,500 plus satellites currently in orbit. That does not count all of the space garbage, the trash, the old satellites that are now defunct and falling towards Earth or burning up in their orbits. It's a bit of a danger zone leaving the airspace of nations. We are now prepared to consider American foreign policy options as they relate to outer space. The trajectory for the United States is clearly linked to the Space Force, which is the world's first and only independent space force. Question is whether or not it will lead to a new space race. The history of arms races tells us it likely will. Let's now consider the options that the United States has in its foreign policy towards outer space. On the one hand, we can look at outer space as the new military battleground. We would continue to pursue the Space Force. We would look into ways to militarize offensively or defensively the outer space region, very likely resulting in a dangerous arms race. On the other side of the coin, we could recommit to the legal regime, the treaties that make up the corpus, and those principles of outer space, pressuring other space nations to do so. We could encourage private enterprise. We could also prepare to limit individuals in their access to space, in their behavior, and in their claims in outer space, keeping in mind that the legal regimes only regulate nation states. They do not regulate individuals acting on their own or businesses that are apart from national governments. So if we are to limit individual activity, we likely have to revisit the legal regime on outer space and adapt it to 21st century realities. It is certainly within the realm of possibility that very soon we will have humans not only visiting the moon, but perhaps living there in very complex communities. While this is a very exciting time in world history, our exploration of outer space is taking on new dimensions and uncovering new realities. The United States government must think very carefully about its policy towards outer space, both relating to state behavior and individual enterprises, because we're looking at a space race that could take on a very dangerous dimension if we do not regulate it early on. Thank you for attending this lecture. Stay engaged and make great decisions.
Hello, everyone. It's my great pleasure as moderator to welcome today's guest discussant, Dr. Scott Pace. You've all had the opportunity to read Dr. Pace's curriculum vitae, which most appropriately is long enough to reach to the moon. Suffice it to note two highlights. He is currently the director of the Space Policy Institute and professor of the practice of international affairs at the George Washington University's Elliott School of International Affairs. And immediately prior to his current post, he served as Deputy Assistant to the President and Executive Secretary of the National Space Council from 2017 to 2020. Among many other honors, he has also received the NASA Outstanding Leadership Medal. Dr. Pace, we're honored indeed that you've accepted our invitation to be with us today, and we extend to you the very warmest of welcomes. The floor is yours, sir, for your opening remarks.
Okay, thank you very much. Very much appreciate that, Michael. So I guess I'm finding myself struggling as maybe as a pedantic academic with finding things to critique in the video. So never mind my government hats and my industry hats from the past, but as an academic, I have to find things to pick at. Overall, I think that the video did a good job of laying out what the general issues are: commercial activities, military activities, how nations relate to each other. But there are a couple of flaws in there, and if I may be so bold as to say, actually, there's some mistakes. The things which I think it's important to understand about space is very different today than in the Cold War. Is because it's no longer just a bipolar regime of us and the Soviet Union, but it's an environment that's much more globalized, much more democratized. And by that, I mean many more countries are involved in space and many more private sector actors are involved in space, which the presenter alluded to. So this makes the environment more complex in how we deal with it. But we, in fact, have been dealing with it for some time. I think one of the ones that really struck me toward the end of the video was talking about how we would have to amend treaties in order to put regulations on individuals in space. That's just not true. In the early days when negotiating the 1967 Outer Space Treaty, the position of the Soviet Union was that only states were proper actors in space, and that private individuals and corporations in particular were essentially pirates and would be illegitimate in space. The Kennedy administration already had ideas for creating a global communications monopoly, which became Intelsat, and already had ideas for a private US firm to be part of that, which was Comsat Corporation. And so the US, of course, rejected the position that private actors had no role in space. The compromise we reached with the Soviet Union was Article 6 of the Outer Space Treaty, which says that persons subject to US national jurisdiction and control are, in fact, then to be bound or overseen by the member states. So unlike the oceans, when you go out into space, if you're subject to US jurisdiction or control, you're bound by the laws of the United States. If you go out on the oceans and become a pirate, your home nation has no responsibility for you, and you can be hunted down and killed as pirates are. If you're in space, however, the member state, in this case, the United States, still has responsibility for you and can't disown you. So the way we carry out our Article 6 responsibilities is we flow down international agreements through licensing and regulation. If you go to the FAA and get a launch license, which SpaceX, for example, does, you go to the FCC for a satellite license, which people do. If you go to NOAA for a commercial remote sensing license, what you will find in every one of those licenses are provisions which require you to obey international law that the US has signed up to. And that can be everything from not placement of weapons of mass destruction in space to deorbiting and disposing of your satellite at end of life in a satisfactory manner. So first of all, we actually do have regulations. Now the question about what regulations we need, how those might change as more private sector actors are in space, absolutely an open issue, and we can talk at length about that. But international law is not the problem. The second thing I would dispute, and again, this is maybe down in the weeds, but it's something that I've had long discussions of with the State Department Office of the Legal Advisor, who I've consulted with over the years as we've done international discussions. The United States never signed up for the principle of common heritage of mankind. That is not in the Outer Space Treaty. We did sign up for the idea that space is the province of all mankind. And there's a distinction here in that the province of all mankind means space is open to people. Everybody should be able to go there. Chinese can go into space. We go into space. Russians go into space. It's a province of all mankind. Common heritage has a bit more baggage associated with it. It's associated with the Law of the Sea Treaty, which the United States did not sign, although we observe the navigation provisions as customary international law. We did not sign the Moon Agreement, which the speaker alluded to, again, because it had this phrase common heritage in it. Space can be thought of as a shared domain, but we don't really consider it a common heritage. Now, some people think it should be, and it could become a common heritage environment, but it's not one yet. A simple way to think about this is common heritage means something which is owned in common, which people all agree to. There is no agreement that space is commonly owned by everyone. So it's kind of like in talking about future regimes, the international law is actually quite open on this matter. So sometimes the phrase global commons is used. That again has linkages to this common heritage idea. It's a wonderful metaphor. I mean, everybody can kind of get the idea of what a global commons might be and everybody moving around within it. But legally, it's actually rather meaningless. And so other things like cyberspace are not a global commons. The polar regions are not global commons. They're governed by treaties. The high seas are not a global commons, except for the true high seas beyond national boundaries, where we've agreed that there are global commons. So territorial waters, exclusive economic zones, those are not a global commons. The high seas, the air above the high seas, those are a global commons, but that's because we've actively agreed that that's so, either by signing a treaty or by customary international law. The Defense Department sometimes will use the phrase global commons, and I know the lawyers at state always cringe because it's just not legally correct. And we never use that language at the UN, and that's been the case for multiple administrations. It was true in Bush 43, it was true during the Obama administration, it's been true in the Trump administration, and I suspect it will be true in the Biden administration, because this is a matter of international law within, sort of the specialist community. And then those are really, I think, really the two really big things for me in that. One of the reasons why I think I like studying sort of space policy, of course, it's cool, and there's rockets and nice imagery and so forth. But as an international affairs school, one can ask, well, why are you studying outer space? Well, because it's one of these areas which is interesting because it's beyond sovereignty. It's an area where sovereign states interact, but it's not lines on a map, it's not borders, it's not classical foreign policy kinds of concerns. So cyberspace, the high seas, the air above the high seas, polar regions, outer space, these are all regimes that human activity has a shared experience in, but which nation states have to work out how they're going to interact with each other. We have some basic law right now, which it's fairly stable, and I think people buy into. We're looking at developing new norms of behavior in kind of a more of a bottom-up manner rather than a top-down manner. And this is important, I'll mention in a moment. We have a new series of agreements called the Artemis Accords, which basically restate major portions of international law, but apply them to exploration and development of the moon. And we've had basically 15 countries now who've signed up for that. The core group started with the United States and key allies, but it includes everybody from Ukraine to Korea to Luxembourg, United Arab Emirates, Italy, the UK. I mean, it's a whole mixture. Russia, China, Germany are not signatories, and they have political reservations. But pretty much everybody else who's looking to be out there has signed up on the Artemis Accords, which is a vehicle for talking about how we will implement international law as we explore and develop the moon and journey on to Mars. The bottom-up phrase I use is very important because international law to date in space has been very much a very top-down matter. A bunch of smart people got together, they wrote ideas, they negotiated between states, and that flowed downward. What's happening now as we have more commercial actors in space is we're looking at bottom-up practices. That is, if I have two spacecraft looking to meet and rendezvous with each other and service and repair each other, that's wonderful. But two spacecraft could also meet to destroy each other. And so how do you know the difference between what's a friendly service call and what's a hostile act? Well, there are technical provisions about how close you approach and when you notify each other, just as there are provisions on the high seas for ships. Do they pass to the right? Do they pass to the left? Do they give signals to each other? These very practical sort of measures that have been developed over centuries for the high seas have not been really developed for space. We're just now developing them. And so before we go and set new treaty law downward, I think it's been important, and again, we've been doing this in the UN, of bringing these practices in, having multilateral discussions of them, adopting them through non-binding principles, but then enforcing them through national law and regulation. So we don't create a new intergovernmental organization, we don't create a new treaty, but what we do create is common understanding of practices, which then are enforced at the national level. So sovereignty always remains with the nation state, but we use multilateral conventions like the UN to increase and broaden that understanding. I've been on transmit mode. Let me just stop right there and defer back to you or to take any questions.
Thank you very much, Dr. Pace. Adrian, do we have anyone lined up to pose a question to the good doctor?
Sorry, I was on mute. Okay, so we have a question from Mike Hammer. Can space controls be any more effective than cyberspace controls? We complain about Russian hackers, but it means nothing if Russia doesn't handle it. And then he says, tragedy of the commons?
Yeah, great question. And in fact, I think one of the criticisms of international space law today is we haven't really used the enforcement mechanisms that are already there. For example, there's a provision of the Outer Space Treaty called Article 9, which is where you get to complain if somebody has, created harmful interference to you. Arguably, the Russian and Chinese and even Indian anti-satellite weapons tests created harmful interference. We did not demarche any of those countries. We complained loudly about it, but we didn't make an Article 9 complaint about these matters. So first of all, you could use existing mechanisms, frankly, better. In answer to how you, enforce this, there aren't really enforcement mechanisms, except everybody has some incentive to get along. I think there is an incentive to hopefully not create more orbital debris because it's really just a problem for everybody. So there is some discussion right now about a brief moratorium, hopefully maybe becoming more permanent, but a moratorium on the creation of long-lived orbital debris, similar to atmospheric and space test bans of nuclear weapons that happened in the early 1960s. We started with a moratorium, and then we eventually got to a partial test ban treaty. I think the same thing could occur with anti-satellite weapons. And the reason it's hopeful, not only is because it's probably in everybody's interest, but it's also verifiable. One of the problems with banning cyber hacks and and even larger calls to ban space weapons, is you can't verify them. No one can really tell you exactly what it is and how you know it if you saw it. On the other hand, behavioral activities like creating a big explosion that causes debris, that's pretty verifiable. And so therefore, a more behavior-based set of agreements probably has a better chance than just simply saying, banning weapons per se in space. But it's very, very similar to the cyber hack situation of lack of enforcement mechanisms and lack of verifiability on these agreements, which of course can lead to the tragedy of commons, as you point out. I see a Harry Rutowski. Sorry, you're on mute. Sorry, you're still on mute.
Well, while Harry gets his act together, Adrian, does anyone else have a question for us?
Yeah, we have a question that asks, should the U.S. confirm?
There he is.
Are you ready, Harry? Okay, go ahead.
Okay, I have a question. On January 20th, 1969, the United States landed on the moon. It was a great accomplishment and everybody took pride in it, great enthusiasm. But then we abandoned the moon. We took the technology that we developed to get there and we literally threw it away and went to the space shuttle. What do you see as the failure of, I think it's a failure of NASA to explain a rationale for space explanation. Do the American people really understand why space is important and what we want to do in space?
Sure. Okay. Giving away my age, in 1969, I was 10 years old and I was in Tomorrowland at Disneyland, and they had actually set up, screens, and you could watch, you could either go on the moon ride or you could watch the guys moonwalking. So that definitely burned an impression on me. And of course, and I was of that generation, some of us call ourselves the orphans of Apollo, who were very disappointed that nothing happened. We thought, hey, we're going to the moon, we're going to build space stations, we're going to, go deeper in exploration. What I did not understand then, and which mostly the American people don't understand today, and I actually have to teach in class, is that going to the moon was not about going to the moon. Going to the moon was about beating the Soviet Union and solving a political problem that John F. Kennedy had. I would commend to you, since we're talking to a library association, there's a book by a colleague of mine called Project Moonglow, which was the name of the public diplomacy operation after the Apollo landings. So Teasel Muir Harmony, she's the Apollo curator at the Smithsonian. And she talked about this public diplomacy outreach, how it was gauged, U.S. Information Agency, and what benefits were done for that. But we weren't doing the Apollo program for space. We were doing it for other national interests. Now, today, when we have so many economic and military equities in space, I think space is more important to the American people than ever before. If we didn't have it or it failed, we would be in a really world of hurt. We would not have a modern society. It wouldn't work. And yet, it's not under sovereign control. So we don't get to really dictate what happens out there. Thus, the answer, I think, is we need to shape this environment by getting other countries to decide to align with us. So that's why things like the Artemis Accords are very important, because you get other countries to align with us and voluntarily help create an environment that supports our interests. And we don't do this because we're space enthusiasts. We do this because we're trying to advance U.S. national, military, economic, and diplomatic interests. And I think, again, a lot of my space colleagues often miss this because they're focused on the space part. What I have found is that if I want an enduring space policy, an enduring space program that survives across multiple administrations, I have to see space as something that supports national interests. It's a derivative, it's a tool. It's not something that exists separate from those other interests. And so in 1969, and of course with the last Apollo landing in 1972, when we walked away, which again I thought was a terrible tragedy, as I think most other people interested in space did. I think it's then incumbent to recreate or create a new space policy foundation that is more aligned with enduring national interests if we really want to see progress. Because simply enthusiasm for space alone doesn't really, as Margaret Thatcher put it, put butter on the biscuit. Wonderful phrase of hers. I think we've done that in the last administration with bipartisan support. And so I'm more hopeful now that we'll have a enduring program. Probably won't go as fast. They'll probably have problems, but it's on a more solid foundation today than it was in 1969. Over.
All right, thank you.
Dr. Pace, picking up on your comments and about cooperation in space, Russia is making noises about abandoning the International Space Station, and it signaled its intent to perhaps join with China in a similar joint effort. Meanwhile, NASA is prohibited by law from cooperating with China in space. Is this something that we should be pursuing with China with proper safeguards, of course? Is one means of developing trust, or is the relationship with China now too tattered to even try to do that?
Great. Again, great question. Charlie Bolden was an NASA administrator, and he went to China, and he sat down with his, well, it's not really his counterpart. The Chinese National Space Agency is really somewhat of a front organization. The real power is in the PLA. But the guy starts off with, "Let me be clear. We do not need you." Okay, great way to start a conversation. And he pauses and goes, "And you don't need us." Well, that's true. He says, "But we could do great things together." Well, that's true too. The Chinese do have capabilities. There are things one could imagine doing with them. The problem, again, that most space people don't really recognize is that space is a lagging indicator, not a leading indicator of cooperation. You use space to cement, broaden, deepen relations that are already pretty good and you want to make better, or you want to symbolize a new relationship. In 1993, we brought Russia into the space station program because we wanted to symbolize a new post-Soviet relationship with Russia. So the political conditions had changed. The Russians also had capabilities that we wanted. They had experience in long-duration spaceflight. They had rockets, heavy lift rockets that we were interested in. So there was a deal to be made with both changed political circumstances and capabilities they could bring to bear. The Chinese really don't have either. They have capabilities, but nothing that's particularly outstanding, although that may change. And the political barriers are just rather gigantic. And so, again, cooperation tends to follow the nature of the relationship. It doesn't tend to precede it. We don't cooperate in space and then decide on the ground that we could get along better. We've had to expend a lot of effort to insulate the space station from competition on the ground. Not just the recent issues with Ukraine, but the earlier invasion of Crimea, taking of Georgia, poisoning of Navalny. I mean, there's a lot of things that we've kept the station insulated from. And the reason for that is not purely utopian. It's because we're dependent on the Russians. They provide the propulsion system for the station. We provide the power. They can't operate without us. We can't operate without them. But that is reflective of a particular period in time in the early 90s, the immediate post-Cold War period that doesn't exist today. We wouldn't redo this, for example, with the Russians if we were starting over today. Similarly with the Chinese, I can imagine cooperation with them on some fairly small items, exchange of lunar samples, exchanging biomedical data, traffic data, making sure our vehicles don't conflict with each other, interoperable standards for communications with each other. There's a lot of things that you can, at a very somewhat technical level, scientific level, do. But high visibility, politically significant cooperation is not going to happen because the overall relationship just won't sustain it. So I'd keep channels of communication open, just as we kept open with the Soviets during the Cold War. But I wouldn't try to put more burden on the relationship than I think it can bear. And it can't bear much at this point. Over.
Do you think Russia and we will be going our separate ways, though, on the space station?
Yeah, we actually, after the space station ends, which will be sometime on or before 2030, we'll probably be going our separate ways. We have agreements with all the other partners, Canadians, European Space Agency, Japan, for cooperation, what's called a lunar gateway, which is a small lunar space station in orbit around the moon that will support operations on the lunar surface. We did offer and had discussed with the Russians them being part of that gateway program itself, because we actually went to all space station partners. And they had thoughts about maybe providing an airlock. That would be a useful contribution. But in the end of the day, they didn't feel they were going to be treated as equal partners the way they're treated on the space station today. And therefore, they basically turned down partnering with us on the lunar gateway, because they didn't feel it was going to be kind of a 50-50 arrangement that they currently enjoyed aboard the ISS. And that's true. It wasn't going to be that way. We weren't going to repeat that. So they've looked to the Chinese for cooperation. The problem is that the Russian space industrial base is in bad shape. They haven't been able to create a commercial industry. They've stifled it with state-owned enterprises. They have a lot of corruption problems. Their ability to earn hard currency has declined as we've regained independence and our own access to space. SpaceX has taken away market share that the Russians used to get. And so they're in bad shape. So I'm kind of pessimistic about them in the long term. Individually, on a one-on-one basis, the Russian cosmonauts are great. I mean, they're brilliant. We trust them with our lives. We work together well, but they're embedded in a system that fundamentally is decaying and is growing weaker by the year. So their relationship with China, I think, is going to be very fraught. As one friend of mine put it, how do you say subcontractor in Chinese? Because they're not going to get a better deal than what they've already had with the United States.
That's
Over.
it.
All right, thank you. We've got a question from Warren. He has his hand up. Warren?
Yes. My question is about whether you could share with us your views of the pros and cons of SDI and whether and what its role may have been in ending the Cold War.
That's a big one. So during the time that SDI was going on, I was a graduate student at the RAND Corporation. And it was a really fascinating time because we were basically, and my seniors and the people I worked for, were basically revisiting a lot of nuclear theory and doctrine that had kind of calcified, or if you will, it had been all this, big stuff had been thought about and done back in the 60s, 50s and 60s. And so in the 80s, it was like, oh my goodness, we're going to re-question all these fundamental issues. So intellectually, I think it was a very interesting time. I think the explanations that the speaker laid out, bargaining chip, actually making nuclear deterrence, nuclear weapons impotent and obsolete, in Reagan's phrase, all of those things I think were present, but they were present in the minds of different people at different times. I think that Reagan himself really had a very moral commitment. I think he was just basically horrified by the whole idea of the idea of mutual assured destruction, which, again, a pedantic point I have to point out, was never a U.S. doctrine. There was never a doctrine. It may have been a result as a practical reality, but it was never a doctrinal objective. But anyway, pedantic point. Reagan had a very genuine, I think, interest in trying to move beyond that. And we actually looked at how could we move from a stable offense-dominated situation where we were mutually vulnerable to a stable defense-dominated system whereby each side felt that there was no point in having a war because you couldn't get anywhere. And these are the two sides of deterrence. There's deterrence by threat of retaliation, and there's deterrence by denial of attack objectives. And for most of the nuclear, the Cold War period, we operated under deterrence by threat of retaliation. It is possible to have a situation of denial of attack objectives where both sides understand that there's no point in starting because they can't get anywhere. But transitioning from one to the other is incredibly dangerous. There are a number of periods along the way where you could, in fact, have crisis instability, and where one side or the other feels an incentive to launch first, or feels that the other side sees that incentive, and then they have to launch first in a crisis. So getting from one point to the other is incredibly hard. And I don't think that was really fully understood or worked out, either because people out of hand rejected that transition as being possible, or thought it would somehow be magically possible and really didn't do the work necessary to see that transition through. I think SDI played a role, maybe not dispositive, but I think it played a strong role in the eventual end of the Soviet Union, not because they felt they couldn't compete against the US militarily, but because it further highlighted stresses in their economy, which Gorbachev belatedly tried to fix with perestroika, which added further chaos, and the system came crashing down. It was already weak to begin with, but the stresses added on by economic competition, by the technological competition as represented by SDI, but not solely due to SDI, helped lead to the end of the Soviet Union. Ironically, the Chinese, in studying the collapse of the Soviet Union resulting from all this, drew several conclusions, one of which is they were critical of the lack of party activity and strength at lower levels. They felt the party structure had atrophied a lot. And so you see Xi Jinping working to tighten his control and strengthen party apparatus in a way that you haven't seen since Mao. And the other thing is they concluded that you had to be economically strong and in order to be militarily capable. So again, they've taken a number of lessons against that. Now, there's a whole nother discussion we can have about Xi Jinping and what his prospects are and success and so forth. But what I am saying is that SDI, I think, did play a role in end of the Soviet Union, but it was not one that I think anybody started with intending. The options that were laid out there before about actually being able to deny nuclear weapons effectiveness or being a bargaining chip or something else, those were the reasons people were thinking about at the time. And I think everybody, including my colleagues at RAND, were surprised by the fall of the Soviet Union. Maybe they shouldn't have been, but they were. So I don't know if that answers the question, but I mean that's my sort of reaction to it.
Well, it does. It's a very thoughtful response. But one of my questions would be, did we actually ever do anything to implement SDI, or was it just an extraordinarily wonderful bluff? Yes, we did. Now, again, part of the problem is people can't tell the difference between what's near-term technology and what's far-term. The X-ray laser stuff was way over the horizon, despite Edward Teller saying, that Livermore could do the job. Kinetic kill vehicles, what were called brilliant pebbles, which came out of a different part of Livermore, were in fact much more near-term, much more real. And there were a number of tests. One of the guys that I met during that period was Mike Griffin, who later became NASA administrator. And he was basically the chief engineer on SDI working for General Abramson. And there he led a number of experiments. There was a Delta 180 experiment, which actually did intercept in space. There was an Army homing overlay experiments that also demonstrated capabilities. A lot of technologies that are now today used in small satellites. You hear talk about mega constellations of satellites. Well, the small set revolution that led to the current situation came about from miniaturization of space parts and components that SDI funded. So in the early 1990s at the Commerce Department, we were looking at replacing the Landsat program, or Earth Remote Sensing System, which was a big, heavy, hundreds of millions of dollars thing. And one of the things we were looking at doing was pulling SDI technology that had been demonstrated only a few years before. Miniature star tractors, small sensors, little momentum wheels, all kinds of stuff that had come out of the engineering development. Now, did they make enough progress to have a deployable SDI architecture? Not at all. Did they make technical advances which resulted in new technologies that then flowed into the space industry and have led to some of the commercial successes you're seeing today? Yeah, they did. One of the first high-resolution commercial remote sensing systems that my office licensed came from a guy who came off of a Brilliant Pebbles program at Lawrence Livermore. So, a physical example of technology transfer coming, out of the lab and into industry.
So yeah, I think there was a lot of things that came out of it. It just wasn't what people were planning for.
Okay, thank you. We have a question from Mike Hammer. Are there any rules around cleaning up space junk?
So a couple of things. There are international rules about not creating more space junk. There are things called the orbital debris mitigation guidelines, which are basically how you should design your rockets and your spacecraft to avoid creating junk along the way. These came out of industry, they came out of NASA, we brought them into the UN and they became adopted and so forth. Although in a form of irony, these were widely adopted at the working level in the UN in 2007, including by the Chinese, which we were glad for because the Chinese Long March rocket tended to create a lot of trash on its way to orbit, and they've cleaned it up and they've gotten better about it over the years. But in 2007, the Chinese later in the year, after agreeing to these guidelines, wound up doing their anti-satellite weapons test, which then created tens of thousands of pieces of debris, and is still a problem with us today because it comes drifting down through orbits where space station is. And it left us with a real conundrum because we said, well, we know they were technically smarter than that, and they knew how to do a cleaner test, and they chose not to. So what is it? Did they intentionally want to have a dirty test? Or did the military just not talk to their technical experts, which is possible but worrisome? Or that, we were talking to the wrong Chinese? What's going on here? And so that deals with the rules for creating things now. We have licensing rules that when you have satellites that you're supposed to basically either deorbit them back into the atmosphere or boost them into a high disposal orbit. For example, if you're a communications satellite way out at geosynchronous orbit, you can't really come home, but you can boost into a higher orbit and basically get out of everybody's way. The pieces of debris.
Yeah.
Somebody's mic is still on.
Put them in a base. Yeah.
Okay, can we mute that mic? Sorry. We can. The pieces of debris that we're most worried about are the satellites that are uncontrolled. So colleagues of mine have gone together and figured out what are the most dangerous pieces of debris. And about 80% of them are spent Russian and Chinese upper stages that are still basically big hunks of metal that are still drifting around, mostly in polar orbits, where a lot of our environmental satellites are. If these things hit each other, they have a massive amount of mass, and that will add even more debris that can potentially lead to a chain reaction, what's called the Kessler syndrome, where debris creates more debris, in which case you're really in trouble. So if we could figure out a way to remove maybe 5 or 6 of these objects every year, and we could get rid of the top 100, we would make a really massive contribution towards stabilizing the space environment. 2 problems. One is who pays for it, because technically we're close to having the technology to do it, but who pays for it? Second problem is these objects are still sovereign property of the original states. The junk that's laying on the moon is still U.S. government property from Apollo. There's no salvage law in space. If you find a derelict drifting along, you're not free to pick it up and take it home. So how do we get permission? What are the liability rules? How do we transfer ownership? That's kind of the regulatory part of it. And that's actually what we're discussing now and what people are working on. And of course, with a sense of urgency, because the space becomes more crowded, the chance of something going sideways increases.
Doctor, that's interesting. It would seem to me, discussing the question of sovereignty, it opens up an avenue for real cooperation on something that would be beneficial to all of the spacefaring nations. The Pentagon, I think, tracks more than 40,000 objects in space that are a fist or larger, a fist size or larger. And they say that there's actually about 10 times that amount of debris floating around in the upper atmosphere. DOD, as I understand it, they've launched a program called Orbital Prime, under which the U.S. Space Force will give companies money, seed money, to develop technology to begin to clean up space debris. I take it you're familiar with that, and what do you rate their chances of success?
Oh, fairly good. I mean, that's a small prize effort, and it's kind of, I think, part of the Space Force idea to sort of be sort of entrepreneurial and go and spark innovation from smaller companies. Sometimes the big primes are not the only ones who have good ideas. Sometimes smaller companies do. But an example of a big prime with ideas, Northrop Grumman has a thing called the Mission Extension Vehicle, which can go up and dock with a geosynchronous satellite and provide extra years of life to it. It could also bring it home. Friends of mine at a Japanese company called Astroscale, they call themselves orbital sweepers, join the sweeper team for cleaning up debris. And a couple of my students have gone to work for them. And they, again, have been doing some on-orbit demos. They recently paused their last one because they were having some anomalies with it, but they're operating on space now to, again, get smaller pieces of debris and deorbit them. The dangerous pieces are the ones that are higher up. Things that are maybe less than 100, 200 miles or so eventually burn up in the atmosphere and decay. But if you have something out at geosynchronous orbit, boy, that's around there for tens of thousands of years. So some regions of space are more dangerous, than others. I think that given a lot of military assets in geosynchronous, the DoD is going to want to focus on cleaning out the geobelt probably sooner. A lot of environmental satellites, as I mentioned, are in polar orbits, which are subject to some of those Russian and Chinese upper stages. So if you're interested in preserving weather and environmental monitoring systems, you probably want to take those out. We all care about space stations, so clearing out debris that could be a threat to the station, including some spent Russian and Chinese debris, will be a priority. So not all areas are equal. Some areas are harder to do than others, but the technology is pretty close. The political and financial aspects of how to do this are not as close. People understand the problem, but there's not really a clear solution yet as to what to do about it or how it's going to be done.
You can't make the argument debris is debris. It has no intrinsic value, just like floating plastic in the ocean. Doesn't it just move us to clean it up?
Well, that's right. That's a very commonsensical argument, but that doesn't always work with lawyers. And one of the ideas, there is a treaty that most all spacefaring nations belong to called the Registration Convention, which says that when you launch something, you have to file the orbital parameters and its name and notice and something about its purpose, although that can be very vague, with the UN. So the UN maintains a registry of all the sort of intentional objects in space that are registered. You could presumably, at end of satellite life, put a little asterisk next to an object and say, this object is now available for salvage. We don't accept any liability if you screw it up, but if you want to remove this object, have at it. That would remove a legal barrier to the addressable markets because the launching state or the original owning state could say, I give up, relinquish claim to this object. I'm not going to pay you to do anything about it. I'm not going to help you, but if you want it, you can have it. Even something as simple as that, I think would be helpful.
Adrian, I think you had someone else in queue.
Oh, yes, in response to an earlier answer, Bonnie says, how can you say we can exchange ideas or information with the Chinese when the world can't get COVID data from them?
Well, because it depends. Saying something is possible doesn't mean something will happen. The problem for the Chinese, of course, in COVID is a lot of the data they didn't want the world to have. And they intentionally obscured it and made it difficult. And I think we're familiar with all the obfuscation and disingenuousness that was involved there. Getting the Chinese, even in the space side, to follow normal scientific rules of exchange is still a challenge. For example, there is a Chang'e missions to the moon. The Chinese were sending both in orbit around the moon and then on the lunar surface. And first one to the far side. Okay, great, wonderful. So they did, and they used communication protocols that were open standard, kind of like open software, if you will. And as a result, Europeans were able to provide tracking and telemetry support for them as they were able to go out there because they were using open communication standards. Okay, great, wonderful. As they get to end of lifetime, there were discussions about if the Chinese would, usually to keep the environment clean, again, orbital debris exists around the moon too. The usual practice is you deorbit your spacecraft into the lunar surface, so it's not hanging around in orbit, being a hazard to anybody. And so they were going to do that with their Chang'e orbiter. And we said, hey, why don't you tell us when you're going to do that? Because we have a lunar reconnaissance orbiter, which takes mapping pictures of the moon in orbit, and we'll get in position and we'll take a photograph of the plume that's kicked up, when your vehicle hits, and the plume will tell us something about the composition of the moon, if there's water, volatiles, anything else in there. It's kind of interesting to look at. You're going to create the plume anyway, and then we'll split the data with you. Okay, all scientists all agree, yep, we're going to go do that. And then the Chinese deorbit into the moon and they don't tell us, or they tell us after the fact. And we're like, all right, what part of exchanging data, didn't you get? Well, the problem, of course, is that the Chinese we're talking to at the scientific level are not the decision makers. Just like many of the foreign policy people you talk to on the Chinese side are not real decision makers. They're not like, our State Department or other ministries. I mean, they're communicators. Maybe they take messages. They're not deciders. And so getting into a habit of open scientific data exchange, meeting commitments that they've made, is still a problem. It's one of the reasons why it's hard to cooperate. We do have some things with them. We have like joint projects on monitoring Himalayan water melt. Not terribly technically sensitive, but of course politically sensitive in terms of feeding into the Ganges River basin. But it's really been on a case-by-case basis. The idea of open scientific data exchange is not a strong suit by any means, but we try to start somewhere.
Okay, thank you. There's another question. Should the U.S. confine its program of space exploration to robotics? What can human exploration achieve that robotics cannot, especially given the danger and cost to the former?
Sure. If you only wanted to do science, you wouldn't send humans. If that was the only reason why we were doing these things, a robotic payoff in terms of cost, risk, yield is certainly better. On the other hand, if you're going there for non-scientific reasons or other reasons, whether it's prestige or engineering or diplomatic purposes or something else, then you can do science along the way. So a friend of mine, Steve Squires, was involved in a lot of the Mars rover missions. And on the Mars rover, we proceed really, really carefully. I mean, you calculate how many wheel turns are we going to do? And the rover moves, so many wheel turns and then somebody else. It doesn't go roaring across the landscape. I mean, it's a very, very deliberate exercise. And Steve is a fan. He's the chief Mars scientist on it, and he's lived all this stuff. And his point was, if I had a geologist and a field hammer, I could do everything the rover did in basically about 2-3 days, as opposed to 2 or 3 years. In terms of productivity, finding a rock, spotting it, figuring out which one I want to go to, what to do next. A human on site would be just orders of magnitude more. Now, affording that and safety is a whole different matter, but humans can do a lot for science if they're there. But if science is the only reason, sure, robots make sense. But the old snarky comment was, people don't give parades for robots, although maybe we identify with them. Having humans up there is the thing that binds a lot of the countries together. Like when we're talking about people participating in the space station, humans are the coin of the realm. A country getting an astronaut to go to the space station or an astronaut to go to the lunar outpost, that is the thing that they want. And we have bartering discussions like how much power are you going to give us? How much habitation time? How much laboratory time? How many tons of cargo are you going to carry? The way I put it with other countries was, look, you help us get to the lunar orbit, we help you get to lunar orbit. You help us get to the surface, we help you get to the surface. And that then becomes a basis for a broad cooperative exercise which shapes the norms and operating principles of cislunar space. We know the Chinese are going to be out there, but I don't want them there without us. And I want me to be out there with my friends who all have an operating agreement for how we're going to be working together. And the best way that cements that shaping of the rules of the environment is with humans. But again, if I was only doing science, I wouldn't have humans. But if I have humans, I can do a lot more science along with it and accomplish other national goals.
Very well put. Going back to militarization of space, which is a very foreboding prospect, the Outer Space Treaty prevents the development of weapons of mass destruction in space, but not regular conventional weapons. Is there any movement afoot to make all space weapons free, or is that simply unrealistic?
I think it's unrealistic because of the dual use nature. I have kind of a trick question for students, which is, if you're aboard the space station and you need a gun, where would you go? And the answer is you would go to the Soyuz and you would dig through the survival pack in the Soyuz, where there's a combination flare gun, survival rifle, and shotgun, along with the satellite phone, which is necessary because in times past, the Soviets period when they had an abort, had one at night. The vehicle landed near the Russian-Chinese border in a snowstorm. The cosmonauts were okay. They cracked the hatch, and there were wolves sniffing around the outside of the door. So subsequent missions wound up, having survival rifles in there, so there are certain exceptions. The problem with space weapons is you can't really define what it is. Is a satellite servicing system that does grappling and refueling, that could be a weapon, or it could not be. I can have something that launches small projectiles for, sending probes out. Well, that can be a weapon system. And I think part of the problem comes with even the definition of term militarization of space. I mean, it's a great shorthand term. Everyone kind of knows what it means. But you can also make the argument, pedantic academic here again, that space has been militarized since 1957 when Sputnik was launched on an R-7 ICBM booster. Military activity has been a part of space from the beginning. It's part of Title 51 of the UN Charter. We have an inherent right to self-defense. Peaceful military activities, including reconnaissance and surveillance that undergird arms control agreements, are military activities. The prohibition is against, aggressive military activities. The prohibition is against weapons of mass destruction. And you can imagine prohibitions against destructive activities like creating orbital debris from ASAT tests that would be verifiable. But space has been militarized already for a long, long time. It has not yet been really weaponized in terms of the way maybe SDI might have envisioned it. And I don't know that it will be. There are a lot of ideas about space weapon systems going back into the 60s, 50s even. And what you learn from looking at a lot of that is kind of never did any of them. We had tests. The Russians have done tests. We did tests. Our last ASAT test was 1985. But we never kind of went down that path because the cost effectiveness wasn't there. The reliability wasn't there. The military case for it wasn't there. So it's not like we were angels or anything, but it really didn't really make a good case for itself. Now, maybe that will change with these new technologies. But I think the main thing is there's continuing recognition about how we're all dependent on space. Ourselves, the developing world, China and Russia. And so keeping space relatively calm and peaceful and stable is something that I think that's in everybody's interests. But how to do that in a way that's verifiable, that everybody will believe, we really haven't seen yet. The Russians and Chinese have continued to propose, largely for propaganda purposes, various prevention of an arms race in space, or prevention of placement of weapons in space. And they've been doing this for decades. Gromyko did it in '82, and they've been doing it since. And there's never been a convincing case about how you would verify any of this stuff beyond good words. And there's never been any treatment, as the Russians and Chinese themselves concede, toward ground-based systems. All the anti-satellite weapons that have been launched so far by Russia and China have all come from the ground. And their arms control proposals don't deal with things on the ground. And so, we look at that and go, well, it doesn't do me any good. I'd like it better if you got rid of maybe those classes of weapons. I'd feel better. But I don't know how I'd verify it, and you're not even proposing to do that anyway. So not a lot to talk about.
Adrian, any other
Yeah.
questions?
Yes, there is. So Elon Musk is fixated on getting a man on Mars and making us a multi-planet species because, in his words, civilization is feeling a little fragile. Won't that fragility simply follow us into space at an exorbitant cost? And what would be the benefits?
Well, sure. Elon's an interesting character. Really, I mean, you got to give him credit. He came in my office in 2002, and we were talking about the first vehicle, his Falcon 1, that he was building, and he was telling me all about how the engine design would work and the injector and what technology trade decisions he was making. And I looked at him and like, Elon, I get all that, and I have no argument with what you're doing technically. I just don't understand the business plan. I don't see how this works. And of course, the answer is that it's driven by a larger, to him, objective of this multi-planet species. Again, a wonderful vision, but from a practical standpoint, there's all kinds of really unknowns there. I mean, we don't really know. And some people say the answer is obviously yes or no, but the real answer is we don't know. Can humans really live beyond the Earth? Are we intrinsically tied to this biosphere somehow in ways that we don't fully understand, whether it's radiation, bacteria, the gravity environment? We don't really know. If we're going to have communities beyond the Earth, it has to figure out some way they're going to pay for themselves. Well, otherwise, it's like Antarctica, and you're always dependent upon the taxpayer somewhere. You have to be able to live off of local resources. Otherwise, you're always getting resupplied from Earth somehow. And that ability to live off of local resources, to pay your own way, to be autonomous, and to do so in a way that sustains life, not just temporarily, but for families, we just don't know the answer to that. And that's sort of the experiment being run. Humans will take their problems with them wherever they go. That's certainly true. It's true on the seas, true on the land. It's been true in the air. And so this is where I think history, in the form of what we learned about international relations and what we've learned about creating, stable, democratic, constitutional governments, is very important. Because we take our values out there. Sometimes I think there's a feeling that it's machines that go out into space and it's astronauts that go out into space, but really it's also our values and the values of a hopefully liberal, tolerant, pluralistic culture, democracy, human rights, rule of law, market economy. These are all things, if you will, products of the Western Enlightenment. So it's not exclusive to the United States, and it's open to any country. I would hope that if there's a human future in space, that those values are part of that. I don't know whether Elon can succeed in that, but I think his vision of a future multiplanetary species is not one that would look like China, despite his Tesla activities in China. I think it is more like that of the West. At least I hope so. And so that's really the test. If there is going to be a human future in space, then what values will that society have? And how do we make sure it can help it succeed? Over.
Yeah, well said. So Dr. Pace, you're Deputy Assistant to the President and Executive Secretary of the National Council from 2017 to 2020. The council was formed in 1989, disbanded in 1993, and then reconstituted in 2017. Can you give us a sense of the brief initial history and what the council is doing today?
Oh, wow. Okay. So going back even further, there was a Space Council, actually under Eisenhower, of a sort, during the 1960 election. It was one of the few times where space was a real partisan issue. John F. Kennedy ran on the idea of the missile gap and getting the country moving again, and Lyndon Johnson, as Senate Majority Leader, was his vice president, and argued that we should pay more attention to space. Johnson's famous phrase, "I for one do not want to go to sleep by the light of a communist moon," was a great speech piece. Kennedy said that if he became president, he would make Johnson in charge of the Space Council, and he did. And Johnson played an important role in space in the Kennedy administration. Of course, as the Vietnam War goes on, and then the Nixon administration, the Space Council really fell into some disuse. One of my early predecessors in that period was Bill Anders of Apollo 8, who was running the Space Council under Nixon. But Nixon disbanded it and a lot of other offices, Science Technology Policy Office, Office of Telecommunications Policy. There's a whole bunch of things that he got rid of out of the White House. And then it went into disuse. The Reagan administration brought back a senior group within the National Security Council, but it was really Bush 41, who brought back the council and had Dan Quayle as the chair of it. And so I worked with that council when I was a career staff, GS-14, at the Commerce Department, and I was a representative from Commerce to that council. We worked on a lot of issues in the immediate post-Cold War period, entry of Russia, China, Ukraine into international launch markets, the first commercial remote sensing satellites, disposal of surplus ballistic missiles, out of arms control agreements. So a number of things that were space and dual use that came up in that period. The Clinton administration disbanded it and said, we can do this out of OSTP, the Science Advisor's Office. And so formally the space people moved into OSTP, but the reality was Al Gore had the portfolio. And so the vice president still played this very important role in space. So bringing the Russians into the space station program was something that the vice president was on point for with the Gore-Chernomyrdin Commission in the immediate post-Soviet environment. And the guys at OSTP were really working for the vice president for all practical purposes. The later administrations, Bush and Obama, had the National Security Council and OSTP people doing space things and didn't have a formal council. And then President Trump brought it back and asked Vice President Mike Pence to chair it. Some of this was a surprise to me, but I got a phone call to interview for the job, and I did, and we hit it off, and I had a great time, frankly. This Vice President Pence was the most engaged and supportive vice president, I think, historically, not only my personal experience, but I think just historically. As COVID hit in 2020, of course, he could spend less time with that. But we got a lot of stuff done. So I'm very proud of that record. The Space Council was then continued by the Biden administration, which again, I'm very happy with, because having that kind of smooth transition or stable transition was very, very high on my priority list. And as a result, we tried to be very bipartisan or nonpartisan in everything we did so that we would have strong stakeholder support to go into the next administration. My successor is a guy named Chirag Parikh, who comes out of the intelligence community. Despite the name, he's from Cleveland, Ohio. I think he's terrific. I knew him when he was on the NSC during Obama, and I think he's great. So they've got a good team there. I frankly don't know that Kamala Harris is going to be as active or as public on space, as Mike Pence was. I mean, for Mike Pence, it was kind of a special interest. But anyway, the team is there, the structure's there. They've largely kept a lot of the policy issues intact. In a very, very polarized town, I often say, not jokingly, there's about two things people agree on. One is space is good, and two, China's a problem. There's no agreement on much of anything else, but there is agreement on those two things. In going forward, the Biden administration has taken what we had been doing, and they've added a new emphasis on norms of behavior in space. They've looking more at STEM education, science, technology, engineering, math education, particularly for minority and underserved, underrepresented groups, and of course climate change. So climate change, norms, education, those are some new things. They've added a couple of cabinet offices that I didn't have in the council. They added interior, education, the climate advisor, and there's one more. Who else did they add? Agriculture. More of the applications end of things. So I don't think they're going to be quite as public and visible, as we were under Mike Pence. But I think they're trying to go in roughly the same direction with and do some of the new priorities that the Biden administration has. So I'm happy for that stability and transition. Over.
Yeah, we got a question in from Daniel who asked, is space tourism, such as that done by Bezos, Musk, and Branson, good, or is it a distraction?
Well, I think the question is a distraction to what? There is no government funding of space tourism per se. We spend a lot of money promoting tourism around the world for economic purposes, but there is no real activity using taxpayer dollars to promote tourism. That's not a public need or interest. But if it happens, great. We'll try to have regulations that make sure no one gets injured on the ground. I think the challenge for the space tourism people is how do they present risk going forward? Flying in space is a whole lot riskier than getting on an airplane. And airplanes, of course, are safe only because we've had millions and millions of flights, and we've driven down the accident rate over the years as a result of having accidents to an amazingly low level. But aircraft don't go even Mach 1 anymore now that the Concorde is retired. Yet in space, you're going to Mach 25 to get to orbit, and you're going from Mach 25 to 0 to come back safely. So it's a completely different sort of environment. How do we talk about risk to people who are thinking about doing this, or how does the industry talk about it? If you want to climb Mount Everest and you're in reasonable shape and well-to-do, you can pay for it. You can pay several hundreds of thousands of dollars to help get a commercial expedition to put you on top of Mount Everest. Now, you also know not only how long it's going to take and when you go, and so forth, you also know from history that there's a 1 in 62 chance of dying on the mountain. If you're over 40, the chances is 1 in 50. So the chance of death, the cost, the location, the time, what you're getting into. But there's nothing like that really in space yet. In the shuttle program, we had 2 accidents out of 135 flights. We lost 14 astronauts. Therefore, the probability of loss of crew is roughly around 1 in 100, which is like flying 66 combat missions in some conflicts. So incredibly dangerous. Actually, side comment, at the end of the shuttle program, and we were looking at successors, our goal with the astronaut office was try to get to 1 in 1,000 or maybe 1 in 2,000 for probability of loss of crew, an order of magnitude increase. Yet that improvement, which would have been amazing, is still orders of magnitude more dangerous than flying in a commercial airliner. So space tourism is a little bit of a misnomer. It's high risk adventure, and there are wealthy people who want to do it. And as long as the taxpayer is not paying for it, and as long as we regulate it in such a way as to prevent harm to anybody on the ground, then I say go forth, have at it. I wouldn't want to have a situation where I would tell them not to try, because that's really an infringement, I think, upon their freedom to take risks, as people climb Mount Everest with their own money, take risks.
Okay, thank you. Bonnie asks, is there any prospect of the US engaging with another country in populating and working on the moon?
Yeah, I think we're working with our traditional space station partners right now. Actually, Toyota has and this Japanese Space Agency have a land cruiser concept in all seriousness that they want us to put on the surface. And we want to put on the surface because essentially it's a mobile pressurized habitation module. I mean, it's a pressurized van, but you can live in it and you can drive it different locations. It's like like a Mars rover, but with a house on it. And that would be a terrific scientific tool, and that's an example of the kinds of things that the major partners are coming up with. The Lunar Gateway in orbit is already going to have habitation modules and laboratory modules provided by the Europeans. They're keying off their experience with space station and looking to contribute to that station, that new space station, if you will, smaller space station, in orbit. There's a number of smaller countries that want to participate that haven't done it at this level before. So looking at, South Korea or looking at UAE, who might want to become involved. And sometimes it doesn't have to involve, humans. One of our counterparts at the UN was we were discussing guidelines for space activities, was the Mexican delegation. And there was this Mexican environmental lawyer who kind of started off pretty skeptical about all this space business, but and was concerned that developing countries would be harmed by being pressured to limit themselves in ways that existing space countries were not. Kind of like environmental regulation is sometimes thought of today as a north-south tension. And though after one of the sessions, I went up to her to congratulate her and congratulate Mexico on behalf of the U.S. delegation and thank them because the Mexican Space Agency had purchased a payload assembly to go on a commercial lunar lander by a company called Astrobotic in Pittsburgh. And so this is a commercial robotic lander, and it would carry cargo to the moon. You would buy a commercial service like we buy commercial services to go to the station. And therefore, Mexico was going to be the first Latin American country to have a payload on the moon. And I said, this is great. You're partnering with a US company to make an advance for Mexico. Thank you for that. Great to work together. Really appreciate it. And she really hadn't been aware of that, and then learned more and took great pride in it. And so the next year, her opening remarks had a lot of comments about how Mexico was being a leader for Latin America and how they were partnering with the US and using commercial technology to do new and innovative things. And I think that's part of the answer is in a more globalized and democratized world, there are a lot more opportunities at many different price points. Everybody doesn't have to be at the multi-billion-dollar level the way the Japanese and Europeans are. Other countries can be part of this adventure, but by picking more modest objectives, partnering with US companies or other commercial companies, including Chinese, they can do that. They can be part of the adventure in a way that maybe would have been impossible to them in the past. I wound up in a meeting the other night with some State Department colleagues, and we were on a telecon or a videocon with Vietnam, who is updating their space policies. And they've bought satellites before. They have a number of space activities. They're worried about their exclusive economic zone, of course. And, one of the things to note is Vietnam launched its very first satellite, a small kind of university CubeSat, pretty tiny thing, but built by university, as a commercial payload because it went to a US company, NanoRacks, which then had leased space aboard a commercial cargo mission to station. And then it went from the cargo assembly to the Japanese Kibo module, which had a dispenser, and the CubeSat was put in the dispenser and fired out of the Kibo module. And the whole end-to-end service was a total commercial transaction. And Vietnam had its first satellite in orbit. And so, these are some of the kinds of things that are possible today. So when you talk about getting more people involved, more people already are involved, and more people can be involved than was ever the case in the past. Over.
Okay. Bonnie asks, what kind of hazard insurance will people in space get? Is there anyone addressing this?
Yeah, there are people who do specialize in satellite and space insurance. You can get insurance for everything up to the time you arrive at the pad. You can get insurance for 1 second after ignition. to orbit. A lot of satellites have infant mortality, so you got to go through the first full solar cycle. So first month or two is when things get risky. You can ensure the revenue stream that comes off your satellite. Largely, rates are driven by the size of the pool. If there's been some recent accidents, the pool size will shrink, and therefore rates become more expensive. If nobody's had an accident in a long time, the pools tend to be bigger and the rates tend to be lower. There's not quite the differentiation there is like in the automobile market, where certain models of cars are more dangerous than others, or certain kinds of drivers are more dangerous than others. There's a little bit of that, but it's mostly driven by how is the overall market doing. But yeah, third-party liability insurance, first-party insurance, all of that is routinely available. I saw Harry had his hand up. Yeah, Harry? You're on mute. You're on mute. Still on mute. Oh, there we go.
Am I still on mute?
Nope, good.
No. All right, I'm going to ask you an unfair question. Make a prediction. When do you believe the first human will set foot on the planet Mars? And will that be an American or a multinational crew?
I predict it'll be, despite what some in the Congress want, I think it'll be probably post 2040, not in the 2030s. And I predict it'll be a multinational crew, but the American will be first because we'll have paid for most of it.
That's a long time to wait.
Exactly. And again, I'm trying not to be partisan here. One of the reasons that while I was in university, after the Bush 43 administration, I was very critical of the Obama administration's Mars plans. I was very supportive of the rest of their space policy because the rest of space policy, frankly, had a lot of continuity to it. So, and in fact, the Trump administration policy we did in 2020, you can just see it flows largely from most of the Obama policy and predecessors. But the exploration one was different because the Obama administration was talking about going to Mars as kind of like, that's the big project, let's go there, let's do this. And the space people thought, oh, that's great, we're going to Mars. Well, not really, because not only was it a long time away, but it also didn't have any on-ramps for commercial and international partners. And, I would talk to space agencies and they would say, Scott, your country isn't really serious because I can't go to my minister and ask for money to go to Mars with the Americans. That's just too hard, too far away. Maybe you and the Russians could do this, but that's just too big a step for me. And so as a result of lack of on-ramps, you could see other countries drifting away from us because they didn't have a way to meaningfully participate. Part of the reason for putting the moon back in place was, yes, there are some practical scientific things and we can test out, exploiting resources and it's technically easier to do and all that stuff. But we can also involve more partners in it and sooner than we can with Mars. So it builds a capability that may result on Mars. But the point is not to have a race, to get there by the end of a decade. The point is to build up a capacity that advances our security and our economic interests more broadly. And that's largely done by leading. And leading today is very different than it was in the Cold War. The Apollo program was like, look how cool I am. I can do something nobody else can. Today, it's like, look how cool I am. I've got all these people who want to be part of my club and want to be part of my team. And the problem with the Obama administration policy is it really excluded people unintentionally. It wasn't their intention to do that. But that structure of not having an intermediate step or an on-ramp resulted in people deciding to go elsewhere. And so when we came back and said, no, we're going to go to the moon the way you guys all had wanted to do earlier, the tables changed. I was at a conference in Tokyo just after the announcement, and it was like a sea change from the same conference a few years earlier. Everybody is like, how do we work with you? How do we work with you? What do you need? How can we get on board? What can we do? I mean, it was very, very, very different. So Mars is very important as a horizon goal. It does excite people and it brings things together, but it's not happening tomorrow. We need to learn to crawl, walk before we start trying to run. And the generation that did Apollo is long gone, and the technology is long gone. It is a completely different world. Buzz Aldrin would give me heartburn about saying, Scott, what are you talking about moon again? We've been there. We've done that. We should go to Mars. And I'm like, Buzz, you know what I tell my students? I says, maybe your grandfather went to Mars, but you haven't gone to Mars. What have you done? And we need to build a new generation of people who have that experience. And that's what's happening at SpaceX. It's happening at Blue Origin. It's happening at Virgin Galactic. It's happening at the satellite companies. There is a new generation who have that knowledge in their fingertips. That's going to be what gets us to Mars. So it may take a while, but I think that's a more solid way to go.
It's very encouraging.
Dr. Pace, your former boss, Vice President Pence, is quoted in the article that we read as saying that space has been transformed into a war-fighting domain. The article also mentioned that the U.S. may soon make a public demonstration of its war-fighting superiority there. Do you have any information that you could reveal to us as to what form that might take?
No.
Okay.
That's still to be settled. The thing about the warfighting domain, this is not something that, frankly, that was new for him. This is something that actually people in the community, the national security community, were talking about a lot during the Obama administration. If you look at the period history of like anti-satellite weapons tests, a bunch of things happened in the 60s and into the 70s. And then there's like a lull, 12, 15 year long lull where like not much is happening. I mean, through the Bush administration, Bush 43 administration, things are really pretty quiet. And you could talk about in the post-Cold War world of a long situation where space pretty much looks like a sanctuary. Maybe not officially, but it functionally was like a sanctuary. Because even then in the global war on terror, where you're dealing, with the Middle East, nobody in the Middle East is launching rockets into space. So our adversaries are not space capable, and again, functionally as a sanctuary. That kind of all changes with the 2007 ASAT test, which is then followed a few years later, by the Indian ASAT test, of course, meeting that, and the more recent Russian ASAT test. There's a number of smaller tests in between that went against points in space that were not destructive by themselves, but they absolutely were anti-satellite weapons tests. And so we see a lot more activity in the last decade or two or decade and a half than we had seen previously. And so in the Obama administration, a lot of the professionals were going, I think we're in a war-fighting world. But there was a political decision not to talk about it that way. I mean, and again, one could understand why, promoting arms control, sanctuary, you don't want to be premature in that. But when the Trump administration came in and said, I'm sorry, this is a warfighting domain because this is what everybody is talking, and this is what the behavior is, and pretending otherwise is not really helpful or honest, then I think we actually could have more of a discussion, because warfighting domain is not just a word. There are vast implications from that on how you organize, train, and equip, what your diplomacy looks like, what technical things you need. As long as you kind of averted your eyes from it, you could go down a bad path. One of the things, though, that even during the Obama administration that happened, and I give credit, like I say, to my current successor, Chirag Parikh, for doing this, was they put some of the first serious money into resilience, that is making satellites harder, producing more backup options, basically being tougher targets, where people had really neglected that for a long time because, the Taliban and the Iraqi military didn't have space capabilities. But now the Russians and Chinese are exercising these capabilities anew. We need to be more resilient. So there are some first steps, I think commendably taken by the Obama administration, but they didn't cross that line into calling it a warfighting domain, which I think was really long overdue by the time the vice president said it.
Yes, makes sense. Adrian, I'm very much mindful of the Dr. Pace's next appointment at 4:00, and we're coming up on that hour. Is there one last question, perhaps, from
there's no questions, just a couple of comments from Mike Hammer. He says the iPhone has more power than all of NASA back in the 1960s, and also that the GPS was originally created for the military.
Both, absolutely true. If anybody really wants to dive into the nerdy end of the pool, there's a wonderful book by an MIT colleague of mine, Dave Mendel, called Digital Apollo, and it talks about the Apollo guidance computer and how that was invented. And so back in the day, Fairchild Semiconductor was, the semiconductor company leading in the country. And the first integrated circuit chips that were bought and then used for operational purposes was on Apollo and to support the Apollo guidance computers. Again, which in retrospect looked very primitive, but let me tell you, they were, cutting edge for, for the day. But the first operational use of integrated circuit chips was that. And of course, the iPhone has much more than that. And again, also absolutely true, the GPS was created for the military. Similarly, the Russian GLONASS system, which is used by, was developed really for the Soviet Navy to geolocate their submarine-launched ballistic missile systems. With GPS, it's been an integral part of the American way of war. We've gone from situations where we took, thousands of sorties and hundreds of casualties to and thousands of bombs to make hit a target in World War II. To later in the Persian Gulf War, having maybe only a few airplanes and a few bombs hitting the same targets, to today where we can take one platform, say a B-2 bomber, and we can assign multiple missiles to multiple targets, and I need one aircraft to take out a number of targets that would have taken, a few hundred of, B-17 runs back in World War II. This also lowers the amount of collateral damage, so we don't create the massive bombing damage. We exact a more precise military impact with fewer civilian casualties and fewer destruction. So we have a hard time imagining how to operate today, without that capability. So you take GPS out and you assume a conflict that's still not nuclear. What does that look like? Well, it looks like World War II, and nobody really wants to do that again. So space is very critical. The GPS market, though, is largely driven by commercial users. GPS military receivers are a very, very tiny, thin slice on the top. The bulk of the market is driven by GPS chips in your phones, is driven by what's in your automobiles, it's driven by construction and survey equipment. And the military and aviation GPS market, while still substantial, is really dwarfed by the larger consumer and business markets. And so that's another example of a sort of a technical transformation that's occurred over the years. We went from GPS equipment being a big box that you looked at. Actually, the first time I saw one in the 70s was a rack of equipment in the back of a truck, to shrinking to a box during the Gulf War, until now, it's disappeared inside your phone. This is your GPS receiver, is a chip buried in here. So again, that's part of the technical flow that space has experienced over the last few decades.
Well, Dr. Pace, I can't tell you how much we appreciate the amount of time that you've afforded us today. You're obviously a very committed and enthusiastic advocate for the space program. And you've enlightened us greatly this afternoon, and we're most appreciative of the time you've given us. Thank you very, very much for being here. And please get on to your next appointment by 4 o'clock. We'll give you a 5-minute break.
Well, thank you, and I appreciate the opportunity, and I appreciate the quality and the level of questions that I get. Maybe it's setting a low bar, but it's better than ones I get from journalists a lot of times. So thank you, thank you very much for the tone that you set here. My pleasure. Thank you.
Thank you, sir.
Take care.
Sure, yeah. Thanks everyone for joining us, and special thanks to Dr. Pace, even though he just logged off, and special thanks to you, Mike. Please join us for next month's program, Myanmar and ASEAN, which will be on Friday, March 18th.
Bye-bye, Adrian.
Bye. Thanks, everyone.